Welcome to day 12 of video solutions for Barvember. Question 1. Always start by working out how many bars we need. Well, we've got his mum, we've got a friend, we've got Ali, so maybe we've got 3 bars. But actually, this is just about Ali's cookies, isn't it? So he bakes some cookies and he does some things with them. Okay, so I think we've got 1 bar, it's what's called a part whole method. So we're going to have a look at all 12 cookies and see what happens to them. So in our bar modeling, our bar represents a number. Now, if we know this number, we write it in the bar. And we do know that this is 12, so we could write 12 in this bar to represent all these cookies. But we can see that we're going to be cutting up this bar. So what we're going to do is we'll put the 12 outside of the bar in this instance and use our curly bracket to indicate that this 12 represents the whole length of that bracket. Okay. So he gives 5 to his mum. So we've now allocated some of this and we do know this number. So we're going to write it in this part of the bar. And we've put in the extra connecting line here to indicate that the 5 just represents this part. He gives 3 to his friend. So we've got another part here and we can write the number in. And how many does he have left? How many does he have left? So that's the remaining part. And we've put a question mark in there to indicate that's what we're trying to find out. So the whole of that worded question has now been moved into our model. And let's see how the maths goes there. And I'll let you follow that through. So there we have it. Question 2. Start as usual. How many bars do I need? Okay, well, I think this is going to be about Rick and Ed, so I'm going to have 2 bars. They've each got 2 cards, so maybe there are 4, but I think there are 2. And the little picture here is giving me a clue that I think I've got going to have 1 bar for Rick and 1 bar for Ed. Now let's really focus on language and see if there's language in our questions which are giving us a clue about the size of some of our bars. Okay, as we work. So Rick has these 2 cards, 45 and 33. And notice how I've made sure that the part for 45 is bigger than that for 33. This doesn't have to be exact, but it just reflects what we know, that 45 is a bigger number than 33. And Ed has 2 cards. And look, this was the clue here, that the sum of Rick's cards is equal to the sum of Ed's cards. So the sum is the total. So that means that the total length of Rick's cards and of Ed's cards must be the same. And it's important that that's reflected in my drawing, because if it isn't reflected in your drawing, then you're going to struggle to do the right maths here. So everything in our problem, in our worded problem, is now in our picture. So let's see how the maths goes. And we use a curly bracket when we're adding, showing that we're adding up 2 bars. And we've done what we can to come up with a total of 78 here. Now we know that those 2 bars are the same length, so we now have a way through to find our missing amount. Question 3. Now, there's loads of useful information in this question, so this is going to be quite an instructive question for us to do. Okay, how many bars? Well, this is about Naz and Millie, so I think I'm going to have 2 bars, one for Naz, one for Millie. And again, we're going to look for clues in language as to how big some of our bars need to be. So there we have it. Naz and Millie. They have some buttons. I've no idea at this stage, so we're going to work in pencil, but those are my 2 bars. They have 400 in total. Okay, so I can show that, and there's my curly bracket to indicate that the 400 represents Naz's and Millie's taken together. Naz gives away 32 of his buttons. Okay. Millie now has 3 times as many buttons as Naz. Now, let's make sure we read our questions as a story, as they do so often happen chronologically. They happen in sequence, and we've got Millie now has 3 times as many buttons as Naz, which suggests that what's happening in this line relates to what's happened before. So Millie now, that's as a result of Naz having given away his 32 buttons. Okay, so we can now finish our picture model that Millie has 3 times as many buttons as Naz, not 3 times as many buttons as Naz had originally, but 3 times as many as Naz had, having given away the 32. Okay, so what we like here is that we've got 4 equal parts, and as soon as we have equal parts in a bar modeling question, it's a really big clue that we've got some multiplication or division heading our way. Okay. How many buttons did Naz have at the start? Okay, again, we've got to be really careful about language here. So this isn't about how many buttons Naz has now, it's how many buttons did Naz have at the start, which suggests that we need a number from earlier in the story, okay, which was how many Naz had originally. So we make sure that when we mark in our question to indicate what we're trying to solve, we've shown the right amount. Now, this is where bar modeling is brilliant, because everything that's in that worded story, which was actually quite complicated, is now in our picture model. So we don't need to refer back to that. We just need to see if we can go ahead and solve this. So let's see what happens. And you follow through the maths. So there's our 4 equal parts. And there's us making sure at the end that we solve the actual question that we've been asked. It's a good question, question 3. Hope you did well on it. Okay, question 4. As usual, how many bars? Well, looks as if I've got 2 shops here. So I'm going to have a bar A and a bar B. Now, we've been looking at language really in the last couple of days, and we'll focus on this in our question to see if we've got any clues as to how long our bar A and bar B are. And as last week, make sure we work in pencil, because it might mean that something we need to modify a model as we get information going through building it. So let's start. There's our bar A and bar B. No idea how long they need to be. Don't even know that bar B is longer than bar A. So work in pencil. Shop A increases their price by 25%. Now we need to know here that that 25% is a quarter. So that's key percentage and fraction connected knowledge that you need to know. Okay, because once we've recognized that 25% is a quarter, then we can see that the shop has increased the price by 1/4. So we now have 5 quarters here. Okay. Shop B increases their price by 20%. Well, again, we need to know that 20% is a fifth. Okay. So bar B needs to be split into 5 parts, and then we're going to add another of those parts. Okay. So here we have 6/5, and here we have for bar A 5/4. And the TV in both shops now cost the same. So there's our language clue, costs the same, that these two bars now need to be equal. And if you've worked in pencil, then you can go back and adjust the lengths of your bars so that you've got this 5 equal parts here and 6 equal parts here, but those 2 bars are the same. So they're the same length, and they must be the same length in your model. Shop B increased the price of the TV by £75. Okay. How much did shop A increase the price by? So let's not forget the question mark, just to indicate what we're trying to find out or solve. So there we've managed to put everything that was in that worded question into our picture model, which is a lot simpler than all those words. So we're going to do our jigsaw puzzle technique and start where you have the most information. Well, the most information you have is what we've already started, and we've started with the 75. Well, we know that these are equal parts, so all of these must be 75. What do we now know? Well, equal parts suggests multiplication or division, doesn't it? So let's multiply those up and see what the total is. Good. Now, as long as we've drawn our model carefully and put some thought into reading the question, we know that our bar for A is the same length as our bar for B. And I'll let you follow through the maths as we finish off here. So that's the end of our video solutions for day 12. I hope you're still enjoying your Barvember and you're getting more proficient at producing the picture models and then identifying the maths to solve those problems. If you're struggling with any of the questions or the video solutions don't make sense, or you think, well, what if this, what if that, then please contact your teacher and they'll be able to help you. See you again tomorrow.